Okie dokes, let me get my clicker ready. Hopefully that's working.
Oh, it's like he's in person.
Yeah, my clicker's working. Yay!
Hey, good.
Right. Hi, everyone. Thank you for coming along to my talk tonight. Before I get started, a quick introduction for those who don't already know me, but you probably do after Pete's build up there. As you gathered, I'm Steve Collins, contract developer based in West Sussex in the UK. As I've got quite a common name, I go by the handle of Steve Talks Code, both for sort of Twitter and my blog and any other place you can find me. Since the start of the year, I've taken over running the Milton Keynes.NET user group, which we do over Zoom as well. We're usually on the second Wednesday of every month, so we don't conflict with .NET Knots and .NET Oxford and what have you. So you're more than welcome to find us on Meetup. I think next month we've got Matty Stratton from Pulumi talking for us, but enough about that promotion. I've got quite a few links in the slides tonight. So what I've done is I've gathered most of them up into a GitHub gist that you can get to through that bit.ly link. I'll have that bit.ly link at the top of the slides, as you can see there. So feel free to go and have a look if you want to go and look into anything. So with that, let's talk about source code generation. Now, this isn't a deep dive. I'm not qualified to do that. We've got two people on the call tonight who are more than qualified to talk about it. We've got Stefan and Jason Bock. So if you've got any really technical questions, ask them, not me. Okay. This is going to be more of a retrospective about my time with source code generation, mainly an old man rant about old computers and 30 years of trying to get code to generate. I'll look at where we're at with .NET 5, now .NET 6, and a bit of .NET 7, and glimpse into a bit of the future with AI writing all the code for us and making us all redundant. What could possibly go wrong with that? I did do this talk at DDD East Midlands, but I've updated it a bit because .NET 6 hadn't come out then. It was all preview and what have you. There's a few extra bits and bobs in here to keep you interested. So hopefully you won't have gone, oh, I've seen this all before, and dip off. As I say, if you do want to have a deep dive into source code generators, go and see talks by Jason Bock, Martin Ulrich, and our friend Stefan there, who did a brilliant talk at NDC Oslo and NDC London, which you should be able to find on YouTube. So that's all the introductions out of the way. Quick sip before I launch into this. Let's talk about source code generation. Now, rather than start with the definition of what source code generation is, it may be better to say what, for the purpose of this talk, it isn't. Okay. So for me, having code that just spits out HTML, CSS, JavaScript, that's not, to me, source code generation. That's code rendering. What this does is generate markup or JavaScript code at runtime that'll be passed and executed somewhere else. Now, the most typical example of that is going to be a web application, be it web forms, Razor pages, that's going to spit out the HTML and JavaScript to go and run in a browser. That's going to go and pass it and execute it there. It's not part of your program as such. Things like TypeScript and Blazor, that's a bit of a gray area because there's compilation and compiling and stuff going on. So I'll for convenience, I'm going to ignore those. However, for this talk, I'm going to cover a bit of these bits. JSON, regex, and entity framework. These are things that generate code dynamically in memory, but execute it immediately. So an example of that is sort of the JSON serializer and .NET regex class in framework. I'm being very careful about what I say there because there's changes afoot that I'll talk about in a minute. ORMs like entity frameworks straddle various purposes such as creating database scripts for SQL, executing queries and mapping data. I'll touch on EF a bit later because that sort of straddles quite a few different bits of what I'm talking about before I get to that. What I do want to talk about is code that goes and writes code for you. And that code gets baked into your final compiled code as if you'd written it yourself. That's where we have .NET source code generators. And that's the bit I'm going to focus on a bit later. But before we get to that, it's useful to look back at the many ways we've tried to generate code over the years. How did I get here? So there used to be this idea years ago that you could roughly guess how old someone is by the first Doctor Who they watched as a kid. Now, of course, that all fell apart when it disappeared from our screens for quite a few years, but I'm not going to let that fact get in the way of a shaggy dog story. So back to the plot. You could be an old timer like me, sort of first came into it with the Pertwee or Baker years, or you could be completely brand new to it. Same goes for source code generation. So if you indulge me, I want to take you on a journey of my journey with source code generators over the last 30 years. Frightening. I'm a time traveler. I am Doctor Who. I'm not really that old, I promise. To do that, we need to go back in time. Now, it'd be lovely if I could do some riff on Back to the Future and say I started with code generators in 1985. But alas not, it was 3 years later. Instead, back in the real world, my first encounter with the source code generator was actually in 1988. And when the slides keep up with me, come on, wakey. Right, so let's go back to my first computer where I learned to program, Sinclair ZX Spectrum. Now, this lovely machine has just had its 40th birthday, and if you follow me on Twitter, you'll see the joy and the disappointment I had over the weekend when I got mine out the loft, fired it up, it actually worked. I got a screen, a bit glitchy, but it worked. And then I found half the keys didn't work, so I couldn't actually do anything with it. You can tell from the photo, even back then I was a complete computer geek because I had a replacement keyboard, not the rubber keys on there, a microdrive that could hold a massive, wait for it, 85K on a loop of tape. Massive. Over the weekend, there was also the 1982 Retro Computer Festival in Cambridge. Wish I could have gone to that, but I didn't know about it until it was too late to book it. But I digress. This may seem an odd place for me to start a talk about source code generation, but bear with me. To give some context, back in the 80s, get the violin strings out now, we didn't have the internet. It's sad, but it's true. We didn't have the internet. We didn't have GitHub. We didn't have Stack Overflow. We couldn't copy paste from anywhere. All we had was magazines. That was the only way you could go and find out how other people were writing code. And you had to get a magazine specifically for your computer. So in my case, it was all these ones about your Sinclair, your Spectrum, Sinclair user, and so on. So each month you'd get a magazine with 2 or 3 programs published in it. And then you had to type in yourself in the dead flesh rubber keyboard of the Spectrum, which is why I got a professional keyboard after that, because that was just horrible. You could say this was in the spirit of open source software, but I think that might be pushing it a little bit. So here we have a typical listing of something that you'd find in one of those magazines. They're mostly written in ZX Spectrum. So give its proper name, Sinclair Basic, which was a great way to learn to program, as I say, by looking at how other people did things. You used to get magazines, you used to get books, you actually got a programming manual with a computer back in those days. However, basic programs on the Specky went through an interpreter. They weren't compiled, so they could be a bit on the slow side. It was only an 8-bit CPU, and if you were lucky, you had 48K of RAM. I started with 16K, and then later there was 128K, but that's a completely separate ramble story. So if you wanted some performance, you had to get around that by resorting to machine code, which meant learning Z80 assembler, which these books, I'm holding them up here in real life. They're some of the ones I learned to program in Z80 assembler. So here we have a section of a program, which you might find a little bit more about later, which is only a handful of bytes long. The problem was that in this format, to have something that was, say, just a few K, it would have taken the magazine pages and pages and pages to print. And print magazines were expensive to produce back in the day, well, as they are now, I guess. So you used to find some other way of sharing machine code in these magazines. So to get around this, magazines used to print machine code listings using data statements containing hex strings. So they'd come with a hex loader that would be able to read those strings, and then they check the decimal checksum at the end to make sure you'd actually typed those 16 characters in correctly. And invariably you made a mistake and it was back to the drawing board. No blue screen of death, it just crashed and back to square one. But to generate those hex listings, you needed a tool. Now, some of the assemblers or disassemblers could actually do that for you, but you had to sort of cough up money, and not everyone who wanted to program could do that. So this is where 1988 comes into the story. I saw this program published in your Sinclair, and it's my first taste of a code generator. And it was written by Tom Baker, not that Tom Baker, a different Tom Baker. The program would scan through memory, create those data statements that we just saw full of hex and checksums, which you could then save to tape. This was the first time that I'd seen, other than an assembler, something that could take some metadata, in this case, some memory out of the spectrum, read it, and generate the syntax to go and create another program. Now, albeit it was just a memory dump, which may not sound impressive, but my story will continue. What got my attention about this was that the feature editor commented that he thought it could have been written in machine code. As you just saw, I'd been learning machine code. Geldler was thrown down. And a burst of youthful naivety, I thought, oh, that'll be easy, I'll write that. Off I went. First challenge. Now, the spectrum was unusual in the way that you typed basic commands. You didn't just type them in letter by letter as you would now in sort of Visual Studio or everything. No. Instead, what you had to do was use this weird combination of cap shift and symbol shift and various key modes and look up the keyword on your actual keyboard to work out what to type in. Made life a bit easier. At least you didn't have to hold all the syntax in your head. It gave you a bit of a clue. So if we turn on our vintage 1980s telly, parents have left it on BBC One again, changed the channel. Okay, let's boot up our Specky. So as you can see here, it's entering the data line and you'll see the cursors flashing with different letters, C, K, and what have you. Those were the keyword mode, caps mode, symbol modes. Those were the different ways you actually entered the text. Now on the spectrum, there were 90 odd keywords to the basic language, which feels incredibly small compared to what we have in modern C# and .NET SDK, where I don't know about anyone else, it blows my mind. I've been doing this C# for 20 years, and I still think I only just scratched the surface. As I said a moment ago, each keyword was assigned to a different combination, different shift keys, modes, letter keys. The way the spectrum language parser worked was in a two-phase approach. The first phase was that you could only enter keywords, text, or symbols depending on that keyboard mode that I showed there with the different flashing cursor. So that kind of prevented you from putting in some bad syntax, but wasn't foolproof. So then there was a second phase where you got to the end of the line where it passed the whole line for any errors and then wouldn't let you enter it if it found anything that was a problem. What this meant for my code generator was that I couldn't just simply read some memory, convert it to hex, and do an ASCII dump. That's what we do if we were doing something similar in, say, C# now. Instead, what I had to do was emulate the program being entered by the keyboard to get the correct keyword tokens and characters. Now, luckily, the book on the left there, this Spectrum ROM disassembly, this had all the different routines in ROM. So you could think of it as an old equivalent of looking at the Roslyn Git repo to see how that handles compilation of C#, for example. But after 4 months of hard toil, and I was a teenager who didn't have a life, I finally got it done. And in true dog fooding style, I used the program to go and create the program that I would send off to the magazine. So I wrote this nice covering letter and sent it off our snail mail, because remember, no email, no GitHub to go and publish it to, on a nice cassette with a listing printout. To give you an idea how long ago this was, it cost 9p to send that first class recorded delivery. I think it would cost at least a couple of quid to do that now. And in July 1989, it was published in USNK. Whoa, fame at last! I'm a bona fide programmer. But if you zoom in, you may notice two things. Even though I said my name was Steve, he put Stephen, and I'm a Stephen with a PH, so only my parents call me Stephen, so that was a bit disappointing. Second is he got a bit carried away with the introduction. Either that or he was taking the mickey at me because it was his last edition. But the single most revolutionary and visually astounding routine in computer programming history. I like that. I wish my pull requests had that on them. But I wouldn't say it was visually astounding. Revolutionary? Well, I'd actually nicked the idea of someone else a few months earlier. But hey, I was a bona fide programmer. Rock on. So moving on a few years, and I diverted. I didn't go into computers to start with. I worked in an administration department because all they could offer me was mainframe programming. I went, no, I'm not touching mainframes. But by about 92, 93, I started using VB3, which felt light years away from Sinclair Basic and machine code. And I was using a proper keyboard on a proper computer, none of this rubber key stuff. So this was the first time I saw a programming language actually start to do code generation based on me clicking a few things in developer tool. So the first time I used a proper IDE, no more rubber keys and assembler. But VB3 code generation was fairly primitive. All it was doing was creating stubs of event handlers for the user interface controls. But this was still light years away from the programming I'd done before. And yes, it was a Hello World example. So for about 8 years, I used various versions of VB, starting with writing Windows applications in VB3 through 4 through 5, and then we get into 6. So by the time we get to VB6, we had Visual Studio and was writing enterprise applications that worked on intranets and this newfangled thing in the late 90s called the internet, using classic ASP. Oh, joy. But to get ASP to do anything enterprisey, you needed to write ActiveX components or COM components with VB. So you got a nice big X there. And because it was a crossover between intranet and internet, nice people at Microsoft decided to come up with that logo. Now, when I say writing enterprisey things, what I really mean is having something that could read and write to the database. Now, you could connect to a database in VB script on the server using DAO, I think it was components, something like that. But most people then were writing this bit as sort of ActiveX/COM components in VB. This was when the 3-tier architecture was all the rage, something that if you saw Connell's talk a little while ago, we were going, no, we don't do that anymore. Back then, a DBA would kill you if you tried to write directly to the database or query the database with SQL from a classic ASP page. So you were down to writing stored procedures on the database and having VB code that would talk to the stored procedures. But even with stored procedures, this still meant having to write a whole load of boilerplate code to pass parameters to the stored proc, call it to execute it, and then you had to go field by field in the columns that came back and map those into results and go through a loop to map multiple columns. It was horrendous. Now, we take ORMs like Entity Framework for granted these days, but these were still several years away. This is still late 1990s, and I think EF was about 2008, something like that. So you need some way of avoiding having to write the monotony of writing all that boilerplate code. So we started seeing tools like this one that was on Database Journal, and you started to find them around. And I think the company I worked for, we wrote our own, but obviously that was proprietary. I haven't got access to that, and that's 20 odd years ago that was written. What it could do is it could read the metadata from your SQL server in the sys tables, sys columns, sys procs, and so on, and go and create the stored procedures for writing CRUD functions, and then also give you the VB code that would go and call those stored procedures, and then go and turn them into objects. Fantastic stuff. But that's still a bit clunky because the files it generated, you still had to go and bring those into the folder that your VB program was in, and then make sure that they compiled. And then if the templates were slightly wrong, it was not a pleasant thing to do, but it did save a lot of time with writing boilerplate. However, things changed, and in 2002, we were introduced to the brand new world of Microsoft.NET. Now, at the time of the launch of .NET, Microsoft's big pitch was the internet was the big thing, and the new platform was there for developers to be productive in all these new web technologies, hence .NET as the name, and, you know, because it's all about the net. And here we are 20 years later, still stuck with that name. But this sent Microsoft into overdrive, talking about things like XML web services based on SOAP. The platform allowed you to write these new services that got applications to talk to each other over HTTP, and this was still all sort of quite new stuff. And if you're from that era, you remember that we had things like web forms to get programmers to program for the web using the paradigms of writing things for VB. But there was a slight problem with all this sort of soapy stuff. All the plumbing to do this was complex because you had to write a ton of code to handle connections, send the request, deserialize the response, handle errors. It wasn't stuff you'd want to write by hand. Luckily, we had things like web standards that were also a big thing coming out at the time. So we got the Web Service Description Language, or WSDL, as we used to call it. This was providing metadata about how these services work. And nowadays we've got things like OpenAPI for JSON services and gRPC. It's a predecessor of those kind of things. This is where we start to get our first taste of something that comes out the box with Visual Studio to actually generate real C# or VB classes, fully populated with code that gets compiled as part of your code without the need for templates. Well, there are a few limitations with the code generation approach. Firstly, the code generation process is manually triggered process. So what do I mean by that? Well, as you would expect, first you need to point to a WSDL file that provides the metadata your code will be based on. In most cases, this would be done using the wizard inside Visual Studio, though there was also a command line tool, service util, I think it was called something like that. But Microsoft had some nifty tricks up its sleeve. If you had a .NET solution where you had both the web services project and the client, you could use the wizard from within the client project to point at the web service project and work everything out from that without having to go through all this WSDL dance, because it did it all for you just by looking at the ASMX code. A couple of years later with .NET 3.5, we got WCF, Windows Communication Foundation, where Microsoft had learned from the problems of the ASMX web services and caught up with things like the web standards to do with security and alternative communication protocols, such as to go straight over TCP, MSMQ, things like that. But I'm not going to focus on that too much. From the perspective of code generation, what are the main things that this did for us? Obviously, the big thing is the ability to craft C# and VB code based on metadata, in this case, WSDL. Now, this is the first time I saw code being generated without the use of actual template files. The code knew how to interpret that metadata and write the correct code. Now, this really hit home to me, going back to the work I'd done a decade earlier with the Databanker 2 application. It was analyzing some data, in this case WSDL, and working out the correct syntax to generate from a whole host of possible permutations. So we started to see comments at the top like this. This tool code was generated by a tool, which generated a RISE Smart. If you look at VS 2019 and 2022, you now get more service options that we'll talk about later. But what I wanted to mention was that in later versions of .NET, we started to see the use of generated code attribute. This can be used by the compiler and analyzers to flag that this is not human-entered code, and we don't want to warn about coding standards, because these hard-coded ones, you had no way of changing it. So if you've got something like ReSharp and moaning about the code quality, not a lot you can do about it. As I say, the problem with these early versions of the tool was it was closed source, and you had no way of stepping in and making those changes to what the code was generating. So if you didn't like the variable naming standards used, tough. You didn't have any way of changing it, though you could wire up your code to events. What was interesting was the lessons learned from these first versions of code generation tools that went on to influence the C# language. So in C# 2, we started to get the partial keyword, which was introduced so that the class could be split into multiple files. One of the drivers for this was so that single class could be made up of code generated file and a developer written file that extends the functionality. Later in C# 3, we got the partial method declarations added. So this allows for authors of code generators to write stub points in generated code for you to provide your own code rather than just wired up event handlers. Because back in the day, event handlers were effectively delegates that were anonymous classes, for want of a better word. So you had allocations and people kept forgetting to unwire the event handlers. It could become a massive memory leak. So with these C# 3 ones, for those of you familiar with the Gang of 4 design patterns, this is an implementation of the strategy pattern. Big driver for this was the Windows Form Designer startup process. So after components were initialized, what happened was the designer would generate some code for you. People would go and tinker around with the code in the wrong place, go and move a button on their screen, and all their code disappeared because it regenerated it all. So this addressed that by sort of separating the designer code away from the code that the developer was entering. However, when these were introduced, there were several restrictions placed on their use. The thinking behind this was that the language and compiler must still work as if an implementation was not provided. And therefore, if someone tried to call to, so if you couldn't call to it if it wasn't there, and therefore it would be optimized out by the compiler. I've listed the limitations here, that it's only void methods, you couldn't have out parameters, and there's no accessibility modifiers. Those are all things that would contribute to having an input or output with these methods. When we get to C#9 and C#10, these restrictions have been removed. But what this does mean is that without these restrictions, you must provide an implementation. Otherwise, Roslyn will give you compiler errors. Now, one of the significant things about that is, if you're aware of the history of .NET and C#, it's the original C# compilers were written in C++, whereas later on, they were rewritten using C# and Roslyn. So there was more scope for flexibility within the compiler. But getting back to when .NET first came on the scene, at language level, we were introduced to Reflection, which finally gave us a way to do true meta programming without the need for templates. So Reflection gave us a way to inspect our code in its most advanced form. It could even generate code using the Reflection.Emit to go and create code on the fly. This was done at runtime. This was the first time they put the developer in the driver's seat to dynamically build types with methods, properties, fields, and events. But if you look at the opcodes, this doesn't look a million miles away from the assembly language I was showing you for the Spectrum. So it feels like a bit of a backward step. It's opcode LD arg1, LD arg2, and AUF. I don't have a clue what all that means. I'm sure people with much bigger brains than mine at Microsoft perfectly understood all that. So it wasn't something your day-to-day developer would really leverage to emit that code on the fly, even though a lot of us were using it to go and read structures of code and do stuff with it. Oh, I seem to have a duplicate slide. Let's try again. Okay. Now, I expect most of you are familiar with the regex class for matching strings against regular expressions. There's that joke, I had a problem, I used regex, and now I've got two problems. Under the hood, regex is actually creating a new class via Reflection.Emit that performs the matching for each expression that you put into your regex expression class. The problem is that by default, if you just use the standard new regex, it's creating a new instance every time it's required. So performance wasn't great. There are a couple of options to help with this that help cache the instance once it's been compiled, or you could even compile it into MSIL, into an assembly file. But that was a bit clunky, especially with sort of rolling code out. So it was great, but not perfect. More on regex in a little bit. So in the first version of .NET, we were working with web config files, and that was a horrible experience. I do another talk about configuration in .NET, and the XML configuration files were something else. You could really tie yourself up in knots with it. You could also embed resources using RESX resource files, and they were very, very similar. It was all XML based, and you could really had to work some horrible APIs to try and read stuff in and out of the res files. So in VS 2005, to help with this, Microsoft added some tooling that would generate static methods for accessing configuration and resources. Now, if you're a solid person, static methods to do all this stuff, you can't override. It was all a bit horrendous, but it was better than nothing. The code that was created, it was done by custom tool code generators. Try saying that when you put a couple of siders. And they were associated with the designer in Visual Studio. I'll talk about that in a little bit more. Writing these generators was not limited to Microsoft, though. You could do it yourself. But the problem with writing your own tool was that because it had to run inside Visual Studio, you had to do a lot of jumping through hoops to work with com-interop. And even now in VS 2022, I think there's still some com-interop stuff going on. But back in those earlier versions of VS.NET, there was an awful lot of com stuff, and you had to fill about with going and creating GUIDs and attributing it and regasm commands to go and register stuff. Absolutely horrendous. And I don't think many people actually wrote these type of code generators. The other problem with the stuff that this stuff spat out was if you edited a source file outside of VS, say in Notepad, that wouldn't necessarily trigger the code generator to kick in again, and stuff you'd have a code file that was out of sync with the text file that was the original source. So whilst Visual Studio added some code generation tooling, there was still room for template-driven generators. So here we have one that I used a lot in my early days of .NET that was called My Generation. And this was back to this template-driven stuff about getting stuff to write templates for calling stored procedures. But it came with its own little sort of, I think it was written in classic VB6 or something, the IDE, but at least you got an IDE with some IntelliSense. It gave you a fighting chance of writing your own templates and them making sort of some sense. But as you probably guessed, these kind of tools fell out of fashion due to the popularity of ORM, such as NHibernate and later Entity Framework. So I think the last time that this was updated was about 2014. Outside of Microsoft, other code generation development was going on in the world of aspect-orientated programming. Most well known of these is PostSharp, but there's also Fody, which is open source. These take another approach to code generation that is known as IL weaving. It's a complicated process, and I'm far from an expert in it, but the key factor in it is that these tools take over the compilation process and intercept the process at certain stages to go and look for parts of code where the developer wants to avoid writing a load of boilerplate. So this might be typically things like going and adding common logging code or property change notifications. As I say, the two main players in the AOP space were PostSharp, which is a commercial product, and Fody, an open source project. That said, I think since last year, even though it's open source and MIT licensing, Fody are now asking for financial contributions to help with it. What's also interesting is I saw some talks from Gail from PostSharp earlier this year, and they've now got this tool called Meta. And my understanding from the talk is that they forked the Roslyn compiler and added stuff in. So it's this hybrid of Roslyn compiler and source code generators from Roslyn and stuff that they used to do in IO weaving with PostSharp. Looks like a really good product. I haven't had a chance to have a play with it, but you may want to go and have a look at it. So when we got to C#3, there came along another way of generating code on the fly at runtime, and that's expression trees. Now, these don't really get much attention, but they're incredibly powerful. And they're what underpins something that nearly every C# developer uses these days, and that's link. With expression trees, you can get right down into the weeds and express what you want the code to do in a tree structure that you examine, modify, and execute at runtime. So your code can actually modify itself and its own algorithms while it's running, which is quite a bit freaky and I'm sure is prone to a lot of errors. So expression trees are not just limited to generated .NET code, though. They underpin Entity Framework in how it translates your C# link queries into the appropriate SQL statements to execute against the database. This is where you get things like iQueryable coming into it. Hugely powerful. I don't want to go into too much detail in this talk, but if you're interested, there is a link at the bottom of the slide to the Microsoft Docs area that walks you through what expression trees are and how to work with them. But a bit like Reflection.Emit that I mentioned earlier, this is not true C# source code generation in terms of something that we can see and edit within our Visual Studio solution. As far as source generation goes, Entity Framework is like the pick and mix store of all the techniques that I've just been talking about. So you've got some stuff that does code generation based on reverse engineering a database. So if you're doing database first generation, though I think that's gone away in the later versions of Entity Framework. You've also got use of expression trees that can convert your link to SQL statements, but using the appropriate provider, so your SQL provider, your SQLite provider. And then you have some reflection going on to bind the data that comes back in that thing of looking at the columns and rows that come out the database and binding that to instances of classes in your data model. Jumping ahead a few versions of C#, when we get to version 6, we see the introduction of the text template transformation toolkit. Microsoft do like to give their things a lot of long-winded names, which are hard to talk about in a talk. So everyone refers to these as T4 templates. T4 falls into two camps. The first is for runtime, where you pass some model into the template and get it to generate some text for you. So that's a bit like the Razor engine that you use with ASP.NET, for example. The second is for design time that can go and generate code based on reading some file. So it's a bit like we were talking about the code generators that earlier. that uses a text templating file generator that associates with a TT file extension. You can say things like, if I've got this file called XYZ, you can go and write your own that sort of says it can take an XYZ file and go and generate some C# code for you. There are a few limitations to T4 templates, though. Firstly, it's very much a Visual Studio thing with limited support outside. I'm not sure if it works with Rider or not, probably not. Because of that, the code that you use inside your template is limited to .NET Framework, as .NET Core and .NET 5 aren't currently supported. That said, since the recent version of Visual Studio, whilst you can't write your template, the code that generates the templates using core code, you can get it to generate code for .NET Core, .NET 5, .NET 6, etc. So earlier I touched on adding service references for SOAP services. Those are still there, but now we have two modern standards as well. So we have OpenAPI, or what used to be called Swagger for HTTP JSON services, and gRPC, which is the new kid on the block that's like the binary equivalent, and it uses protofile definitions. So for REST clients, the wizard adds an OpenAPI reference to your project file, which adds a call to some NSWAG libraries as part of the build chain. This isn't well documented, so I wrote a blog a while ago, must be about 18 months ago now, and there's a link at the bottom of the slide to that blog post, and it shows you how to go and configure the output exactly as you want it. I've also got a link there for the NSWAG project on GitHub, where you can download an IDE for generating client and server code for .NET Framework and .NET Core. Brilliant work by Rico Suter. What was interesting was .NET Milton Keynes last week, I think it was. We had Rahib, or also known as BB, talking about a new tool that Microsoft is developing called Kyoto. And that does a similar thing to OpenAPI reference based on NSWAG, but this is cross-platform and cross-language. So you use it as a tool that you could generate PHP, Ruby, Python, whatever you want. They've got all sorts of providers for that. So you're not tied into the .NET world as such with that. That looks a really interesting project, and it's sort of still in motion. And I believe that there may be some work to bring it into the VS tooling, where you can either say use Kyoto or NSWAG to go and generate your HTTP client code. For gRPC, as well as client proxies that we get with OpenAPIRef, because it's all based on the proto files, you can also generate a stub of a server as well, or you could get it just to generate the domain objects as well. I'm not going to dig into that too much, but there is a link there to the docs page. So for all the .NET generators I've covered off so far, we have had one or more problems in terms of just getting code to generate some source code for us within our projects. They've either been too complex to understand and write, such as the IL-based ones using sort of Reflection.Emit. Some are just plain complex to use. The tooling is horrible. Some are external tools that run outside Visual Studio, and therefore you have to make sure you're running your tool so that it keeps in sync with the code that you're writing elsewhere. Or it's limited to Visual Studio, so you can't do stuff outside. Some are limited to .NET Framework, or only have a subset of .NET Core or 5 support, or 6. And some are closed source, so you can't make any changes to what or how they generate. So that's been about how we've done code generation in the past. What about the present? That's probably a good time to have a break, Jess and Pete. Any questions?
I think you're right, Steve. Pete's just gone to put his kids to bed.
I'll keep quiet then.
I don't want to wake them up. But I do need to pee. So that's quite a good point. We're going to take a comfort break.
Do we want to have a break for 5 minutes then? Sounds
good to me. Thank you so much so far, and I'll see you in 5 minutes.
Okay, I'll go on mute.
Okay. Feel free to chat amongst yourselves while I go.
If anyone's got any questions, I'm not going anywhere. I'm just going to have a sip of water. If anyone wants to ask any questions, come off mute. Oh, you can't come off it. Hold on, I might be able to do something because they've made me a co-host. security. I'll let you unmute. Right, okay. I've taken control of the user group while they've all abandoned me. So you should be able to unmute if anyone's got any questions while Jess has disappeared.
I'm prepped for round 2. I've got my chocolate brownie and my glass of milk.
I took the liberty of letting people unmute themselves to ask questions, but no one asked any questions. So,
Oh, it's because you've just explained it all so clearly, Steve.
what, my Clifford the Big Red Dog voice?
Yes.
Sorry, I had to nip off and say goodbye. Say goodnight to the kids. So I've just come back. What a miss! What a miss! Do it all again.
No, nothing. We just came to a convenient break. So I needed a sip of water. No questions. So I'll have one last sip of water and we'll carry on.
Sorry, I realised I came off mute, video instead of mute then. My bad. If you had a clicking, it's because I was taking out my braces.
Right. Can everyone see the New Hope screen?
Yep.
Cool. So, where was I? Are you sitting comfortably? I shall continue. So we get to 2020 and source code generators in C#9 and .NET 5. The New Hope, could this be the savior of everything that I've been struggling against for the previous however many years it was? Let me find my clicker. Where's my clicker gone? Okay. Now, I know that .NET 5 went out of support earlier this month, but I still want to talk about it as this was an important landmark in terms of source code generation. With the release of .NET 5 and C#9, we were introduced to C# source generators. That's a tongue twister if you've had a few drinks. Technically speaking, these aren't really to do with C#. They're a feature of the Roslyn compiler that's been made accessible as part of the C#9 release. So how do these differ from what we've talked about before? First and foremost, you write them in C# and they generate true 100% regular C# code. No MSIL, no opcodes, nothing. It's proper C# code. Secondly, they're not tied to Visual Studio. The whole process isn't tied to Visual Studio. It's wholly about Roslyn, which of course Visual Studio is using underneath to do its IntelliSense and to do the compilations for you. However, unlike the IL weavers, it can't rewrite code that you have written. So remember how I was saying like PostSharp can go and sort of go and tweak itself as it's running. This is append only code. So all it can do is create new code that either stands on its own or extends one of your classes that has been made partial. So these new generators can be as simple or complex as your requirements demand. Ultimately, the core of the generator is building a string that will get emitted to an output C# file that gets compiled in the same way as you would write your own code. There's no need for templates unless you want to go down that route. I'm going to put a fan on because it's getting very hot in here now.
Because your talk is fire.
You tease. What I really like about these is that you don't have to compile them and to distribute them to your team. Whilst you can go and create NuGet packages to share if you want, if the generator is specific to the solution you're working with, you can just have it as a project file and reference that project from elsewhere within your solution. So in C#9, to write a new source generator, you need to implement the iSource generator interface. This has two methods that I'll talk about in a minute, but to be able to reference that interface, you need to set some dependencies up in your project. So there's a handful of libraries that you needed to write a source code generator that I've shown here. Now, this is slightly out of date because this was based on the .NET 5 version. I wanted to keep this introduction about .NET 5, and then we'll talk about .NET 6 later. But I think it's just going to be slightly later versions of NuGet packages. A key thing to note about the generator is that it needs to be set as a .NET Standard 2 library, not .NET 5 or .NET 6, etc. Reason for this is that, as I said earlier, Visual Studio can only handles, but it can't handle .NET Core, .NET 5, .NET 6 as code to call. So it has to be written in .NET Standard for Visual Studio to be able to use it, as well as Roslyn to be able to use it. Since VS 1610, which was one of the versions of VS 2019, Microsoft have added debugger support to it. But to make the most of it, you need to add the isRoslyn component property and set it to true in your CS_proj file. So there's two methods to the interface that I mentioned. The Initialize method is called when the compiler first starts up, and this is where you register your generator into the compiler pipeline to go and listen for syntax changes in another code base. For this, you write a syntax receiver, which will pass the syntax tree to determine if you need to run your generator based on the syntax nodes within the tree. This is where source generation differs from previous things in Visual Studio, as the generator can be triggered whenever there's a change in the consuming project. If you're not listening for syntax changes and only using, say, additional files like JSON files, XML files as your source, you can leave the Initialize method out. Next, we actually get into the real meat of things. We have the execute method. So this is where the action happens and where you generate the code that will end up in your consuming project's code base. Your logic will either be interrogating code in the syntax or semantic tree that is passed to it via the context. You'll be reading additional files such as JSON, or you can be reading additional files such as JSON or XML files, CSV files. I've seen all sorts of examples. I'll cover that more in a second, but the most important thing to note is that ultimately you will end up with a string containing the code that you have generated. To feed this back into the Roslyn compiler process, you need to add that string into the context using the add source method at the end of your execute method. Now that's an awful lot of sort of words and terms, so it's probably easier to sort of try and explain it with this diagram. So I've taken the diagram from the MS Docs file and just added a quick animation to it. But basically, your compilation runs, the source generator steps in, it analyzes the source code, generates some new source code, adds it in as input back to the compiler, and Roslyn carries on with the compilation. This is where it comes back full circle to what I learned in the generator I wrote 30 years ago for the Spectrum. Same as it ever was, to quote the song, it's all about understanding the language syntax. But this is where I was having to understand how to generate code that would withstand the Spectrum's basic parser with all our source generators. However, in the case of source generators, the input is code, and somewhat, I'm tripping over my words here. Let me try that again. However, in the case of source generators, the input is code that someone has written. So to work with this, you have to understand how C# syntax trees work. But before I go into the C# syntax trees, let's go back to the Spectrum code that I showed you earlier that I did in DataBanker. So in this snippet, it's passing the incoming code to work out what memory we want to dump into a program. So the first bit of code highlighted on the right is the syntax to start the machine code routine, which was this really weird syntax of randomized user and a memory address. That was basically your entry point into your bit of machine code. So then I did a fiddle based on the Spectrum's basic syntax. The first thing the code generator does is check that the keyword after the colon is expected is poke keyword. It then goes and gets two parameters which have already been allowed by the basic parser, which is our memory location and the number of bytes. If all's good, it starts the generation process. If something's wrong, it'll return an error. So that's horrible code. That's Z80 assembler machine code. But to all intents and purposes, that's what we're doing with the C# source code generator. What we do with the C# source generator, if we're looking at syntax, other people's code, and not just taking a JSON or XML file, is pretty much the same and a lot easier to program and understand. So let's start with syntax and semantic trees. If you've ever looked at writing a Roslyn analyzer, you may already be familiar with these, but I'll go through it for those that are not. When you write your C# code, every character contributes to either become part of one of these three categories. Starting with the simplest on the left, we've got trivia. So this is mainly stuff we're not interested in. So it's your white space formatting, comments, preprocessor directive, which are your hash lines saying things like if debug, stuff like that. A lot of that we're not really interested in. Moving into the middle, we've got tokens and the next lowest level of syntax that can't be broken down any further. So these are our keywords, our names of variables, the literals, the punctuation, such as the end of statement, semicolons, things like that. So this is the bit that's not a million miles away from what I was doing of looking up all the keywords on the spectrum in that syntax table in the spectrum. This is understanding what all these keywords mean and how to take advantage of them. These all then get bundled up into syntax nodes, which are groups of tokens that form declarations, statements, clauses, and expressions. So these nodes are effectively your program split out into a syntax tree that can be queried with code. So let's take a typical hello world. Now I've deliberately written this in the verbose sort of old style, not the new top level statements, as I want to show how a simple thing like the namespace breaks down. So first we have the namespace declaration on node that contains all the component syntax in the line. As I said, nodes are containers for other tokens, trivia, and other nodes as well. So inside the namespace node, we have the namespace token. I'm having to look across multiple screens here. So then we've got our white space. And then we've got the identifier token, which is the name of we are giving to the namespace. And lastly, we have the line end trivia. So this is how it breaks down into those three categories of stuff that I had in the previous slide. Now, if you have the basic install of Visual Studio or you're using some other IDE such as VS Code or Rider, there's a great website called SharpLab.io. Here is where you can paste some code and do various things that look like the IL that will be generated by your code. But the feature we're interested in here is viewing the syntax tree on the right. However, if you're using Visual Studio, you get a better tool. But before I move on to that, you can see this breakdown of what I had on that previous slide where I got our namespace declaration, namespace keyword, the end of line trivia, the namespace, and so on, so on, so on, so on. So that gives you a sort of just a tree view like the syntax tree that we're going to interrogate. But if you have got full fat Visual Studio, you need to install some extra components such as the modeling SDK and the DGML editor. If you go and do that, now this was in 2019, I believe they're the same in 2022 when I looked at it. Then you get a nice exploded tree view that you can turn into a directed graph of the syntax tree. So if you look, we've got our name to the top, we've got our namespace declaration node, our namespace token, the identifier, all the stuff that we've just shown there, but it's an exploded directed graph this time. Now, so far, we've concentrated on syntax analysis, but that's not the whole story. While the syntax tree tells you about what the code looks like, so you can spot things like attributes, the keywords being used, stuff like that, there's also a semantic tree. And that's the thing that gives the code some meaning. A bit like Reflection, where you can look for methods and properties on a type from the metadata of the generated code. You can do the same from the semantic model, but this time it's at compile time, not runtime, which you'd be doing with Reflection. This is what makes source generators a good replacement for anywhere that you've currently got reflection code. But you're not just limited to looking at C# code. You can inspect other files that are marked as additional files in your consuming project. So for example, you may have some data in JSON or CSV, as I said earlier, and you may want to convert those into maybe enum types, or I did some stuff where I did a metadata declaration of what entities would look like, and then that eventually spat out C#9 records. Fabulous things, C# records. Go look at them if you don't already know about them. If you're ambitious, you could even write your own language like Dylan Beatty did with Rockstar and write a parser that will transpile it into C#. Who knows? But to summarize why source generators are so great compared to what's gone before, for me, part of the compiler chain and not being tied to Visual Studio and not having to use external tooling opens up all sorts of possibilities. Being part of the chain means that the compiler generates the code for you as it reacts to changes in the source code. This means, this is more of an IDE feature about calling the compiler as the code is entered, but it does mean that your code base of both your code that you enter and the code that is generated is constantly being checked as you type, and it's all in sync. Having additional files means that if you want, you can go and create your own domain language and you can compile that into C#. What I like most about it though is that all the stuff I used to do in Reflection, which was a runtime thing and could slow things down, you can now do it compile time and it's baked in, so you're going to get much better performance. Lastly, with the improvements made to Visual Studio 2019 and 2022 to support code generators, you can now easily get to the generated code and get IntelliSense when you're referencing it in your code. Like all generators that we've gone before, here comes the downer. There's some, it's not perfect. The first thing is the generator project needs to be that standard 2.0 project, not .NET 5 or .NET 6, because it needs to be compatible with Visual Studio. The next is the generator may get called hundreds of times while editing code in Visual Studio. So you definitely don't want to be relying on things that go and do lookups in databases or making calls to HTTP services, because you really don't want that happening every time you're typing a character into Visual Studio or Rider, for example. That's a big no-no. You definitely don't want to do that. And also, if what happens if you've got not only latency, what happens if your network connection breaks? You just don't want to be doing that. The last is that you are limited to generating C# or VB. You can't create regular text files, though I do believe a change has been proposed. I don't know whether it made it into Roslyn before. Perhaps Stefan or Jason might know more about that. But what happens when your generator doesn't work and there's problems with the code that is generated? It's broken. What have I done? One big problem when debugging is that Visual Studio will aggressively cache the generator the first time it's built. So if you make a change to the generator, you will need to restart Visual Studio for your changes to kick in. Now, this is painful. So in these cases, what I do is I drop down to the .NET build command line and attach Visual Studio as a debugger. If you don't want the debugger firing off all the time, you can create alternative build profiles and put a compiler if directive in place. So debugger is only launched if you compile using that profile. So here I've got an example where I've just created a debugger profile and a debugger constant that says if debug generator and the debugger isn't attached, then go and launch the debugger. And that way you can say, I'm only going to build it using that build profile when you're debugging it. Otherwise, when it's building in regular debug or release mode, it doesn't hit that breakpoint. A better way of doing this, however, is to debug your generator to Stefan's got the debug generator. Better way to debug your generator is to write unit tests. This gets a bit messy as you have to write lots of code to be consumed by the compiler and then force a compilation via the compiler API. But at least it's repeatable and you're not relying on things like Visual Studio to do stuff. It does get a bit messy, but what it does give you is the ability to test different scenarios, set breakpoints, and step through your code without Visual Studio getting in your way. So I've got a couple of links here, but I've put them all in the gist that you can see via the bit.ly link at the top. The first is of links to a whole load of source code generator projects that you can look at and see if someone has already written something for you, if you want to use a generator. The second is some general guidance about writing source code generators. That's probably a good point if there's any questions, Jess or Pete.
Nothing in the chat.
Nothing in chat. Okay, in which case I'll carry on. So that was when things got introduced with .NET 5. When I gave this talk at DDD East Midlands, .NET 6 was just around the corner, but obviously that came out in November. So some of the stuff that I sort of said was coming down the line is now part of the landscape. As part of that, Microsoft have started to use source code generators to actually make some code improvements of its own. The first is the Razor compiler, and there's not a lot to say about that other than it's been turned on by default and gets a bit of a performance boost. So back when this was in preview, this was the graph that was shown on the blog about it to say about the improvements in Blazor and MVC by using the Razor compiler. For logging, you can now write a partial method with an attribute, and the generator will write a lot of the boilerplate for you. So at the top, we have a partial void method decorated with an attribute to set the event ID, level, and string template for the message. Below that is the code that gets generated for you. There's a few limitations to this that are listed on the blog side, but it's a nice touch, even if it's just automating the is enabled check. But when I was talking to some friends who've been using that, they said there is a performance boost to it, so it's worth bearing that in mind. The big one that people were getting really excited about with .NET 6 coming out was the enhancements to JSON serializers. Now, if you're still in Framework or even using sort of .NET Core right up to .NET 5, the version of the serializers you were using there still took the traditional route of using Reflection to do all the heavy lifting. With .NET 6, as I said, Paul Newton, James Newton King, Pete's part. With .NET 6, Microsoft have grasped Metho and added functionality that takes advantage of the source generators, not only to handle the serialization, but also to do stuff with the data model via JSON serialization context. What you do get is you get two new generator options. One generates code that optimizes the serialization process. Sorry, I'm going to have to move the chat out of the way. I'm getting distracted, Pete. You do get two new generator options, though. One generates code that optimizes the serialization process, and the other optimizes the deserialization process. In most cases, you can use both of these together, but there are some situations, such as async serialization, where you can't use the generated serialization. My clicker stopped working. I'm going to go back to my mouse. One of the problems with .NET 5 version of source generation is that it could slow down your IDE, as each key press could potentially trigger a new generation. As I was saying, that each time you're doing a key press, IntelliSense would kick in, and also it would then call the Roslyn compiler, which in turn called your source generator. With .NET 6, and more really, it's about version 4 of Roslyn, the new incremental generator interface was added that allows you to add a pipeline which filters out any code that you're not really interested in. That way, you only trigger a code generation if your syntax criteria has been met either by new code or some code has changed. So what's coming up in .NET 7? So details are scant on the source code generation. I alluded to sort of this stuff about Kyoto maybe being added in for OpenAPI, but the stuff that has come out of Microsoft is that the main thing is that they're now going to be using source generators for improving regular expression, both in performance and functionality. I've got a link to the blog there. Because .NET 7 is still quite a few months off, I'm not going to go into too much detail, but I have sort of taken from that blog the examples of what we had before and after. So before, the old way of doing it was you were newing up a regex and putting your regex expression in and say, I want to compile it and ignore case. And then it would do the is match. So behind the scenes, this was newing stuff up, and you had some performance problems because if you called it iteratively, it would be creating a dummy class behind the scenes for you. And that was taking up allocations. Now with the source code generated version, you write a partial static regex and decorate it with an attribute with your expression and any other options like the ignore case. And that will go and generate a load of code behind the scenes for you that's actually going to get compiled. So it's not doing the old style regex way of doing stuff with reflection and doing stuff on the fly. It's going to be baked into your code. And I think Microsoft have also, I'm right in saying Microsoft have also taken some opportunities to do some stuff with recursive regex functions as well. So that's where we're currently at with source code generators. Any questions here, Steve?
Good chance for people to type questions, but Pete's just trolling you mostly.
I know, that's why I moved chat out of the way. You're putting me off, mate. Put me off.
I can't do regex. The only thing I could do with regex is what I've written in there. I just search on Stack Overflow for the thing I want to do.
I think that goes for 99.9% of the programming population.
For any prospective speakers who are sitting in the audience or watching this on YouTube, we do normally keep Pete in line.
Yeah.
Somebody put 50p in tonight.
I'll let Pete off. He's a good mate. I'll let him off. I'll let him off. So we're almost done. That's where we currently are with source code generators. But one thing I do need to point out is with all this power you gain from generating code with source code generators, there comes great responsibility. Why do I say that in a funny voice? That's a different question. But why do I say that? Given that source code generator has access to all your source code as part of the compilation process, do you know what it's doing with that source code other than generating more code for you? In other words, if you're using a generator that's been pulled down from NuGet, do you trust it not to be a bad actor and do something nefarious while looking at your code? So you may have heard of the SolarWinds hack at the start of, I think that was last year, wasn't it? Where hackers managed to sneak in code via an unsecured build process. Whilst this is not specifically about source code generators, it does raise alarm bells about what are known as software supply chain attacks. VeraCode has published a blog post about the potential weaponization of source code generators to inject malicious code as part of the software build process. From this picture that I've taken from the post, you can see what looks like an innocent code generator NuGet package can create code that will eventually make its way into your own software, and you won't know anything about it. Friday. So what it does mean for us developers who have the need for source code generators and want to use one already available on NuGet, what does it mean? We need to do some due diligence to see if you can trust the generator you plan to use. Given that source code generator has access, do you trust it not to do log in its code analysis results, or rather sending it over the internet immediately hiding it away in some log files for collection later? Second point is more about code that is generated. Do you trust it, the code that it's going to generate isn't doing something nefarious? Are you reviewing the code that is being generated as part of the pull request before it gets merged into this main CI pipeline? So since version 16.10 of Visual Studio 2019, you can actually see the generated code by navigating to it via the Analyzers node in Solution Explorer. It's worth saying you should check the generated code both in debug and release mode in case there's some difference in the code generated with those different build profiles. Of course, the most obvious way to determine whether to trust the generator is to look at its own source code. Most of the ones on NuGet are open source with the code on GitHub, but can you be 100% sure that the package on NuGet is definitely built from the source code in the repo? If it is a commercial package, where you do not have access to the source code, do you trust the vendor? If so, has the package been digitally signed to ensure that it actually has come from the vendor and no one sort of stepped in as part of that source code supply chain? Now, both these points apply to NuGet packages in general, but given that source code generators will be looking at your code and generating code, you do need to give this some thought after the SolarWinds incident. And while I was at NDC London a couple of weeks ago, Claire Novotny did a really good talk about the security that's been added into sort of NuGet package generation now. So when that comes out on YouTube, definitely worth having a look. So we've established that source code generators are great, but need to be used with care. Where's all this going though? Things I've talked about around for the last sort of hour and a bit They'd have totally blown my mind when I was writing that generator on the Specky all those years ago. It seemed like science fiction. But my kids are taking a lot of this stuff for granted now. They're a bit older now, but when my kids were at primary school, they were using things like BBC Microbit and Scratch. So as you can see here, it's just a drag and drop interface. You can type stuff in. And then when it gets to the end, I'll wait for the video to catch up with me. Do a little dance, press play. Now, what I like about this over, say, Scratch is that you can actually see the source code it generates in Python or JavaScript. But it's not just in schools. We're starting to see no-code and low-code solutions in business with things such as Microsoft's Power Platform. Now, there's been a lot of buzz lately about GitHub's Copilot, and we've heard sort of Microsoft IntelliCode in Visual Studio for a while. Now, this is quite scary stuff. Now, I know people like Dan Clark have been playing around with it, and it blows your mind that it knows what you want to do. So these tools look at knowledge gained from analyzing public GitHub repos and understanding common coding practices, and then guessing how they can help you with your own code. So we've got an example there in TypeScript, but I believe it also works with C# as well. Taking this a step further, the OpenAI context engine that GitHub Copilot is powered by has been shown off how it can generate JavaScript from natural language. I've got a demo video here on the web from its website. I'll leave it playing for a couple of seconds while I get my voice back and see how it generates a little game. Hopefully everyone can see that. It's not too low a resolution.
No, it looks good.
Yeah. Make it smallish. Computer, make it so. And then this is the frightening stuff, because what if business analysts could use this and it does us programmers out of a job? Frightening. But it does go on for quite a while, but I'll cut it short there. Taking this to the extreme, a team at NVIDIA used its GameGAN AI engine to recreate a fully working version of Pac-Man for its 40th anniversary. Now, what is very cool and very, very scary about this is that it did this by analyzing 50,000 games of Pac-Man being played. No, the AI engine was able to do all the code generation. There was no game engine involved. It worked all out itself. That is super scary stuff. So I've been prattling on for about an hour and a quarter now. You'll be pleased to hear I'm coming to an end. In summary, source code generation comes down to two main things. Metadata provides the input for your source code generator. This could be from any number of sources, as we've seen. It could be sort of memory, it could be JSON files, it could be other C# code, it could be VB code, it could be all sorts of things. The second is about syntax. You need to understand, firstly, if you're reading syntax, you need to understand how that syntax works, but more importantly, when you're generating the code to construct it, you need to understand the syntax so that the code you generate doesn't blow up when Roslyn comes along to try and compile it. To do this, you need to do lots of testing to ensure that whatever someone throws at your generator will still generate the code that compiles. And that wraps it up. I've just about got some voice left to say thank you for coming and listening to me this evening. As I've said, there's links on the slide as to the places where you can hear me waffle on about other things to do with .NET. Please come along to Milton Keynes.net user group. We're a friendly bunch like they are at Knot, so we'll be more than happy to see you come along. And if I haven't sent you all to sleep and you do want to hear me prattling on, I've been on a couple of podcasts, and you can find various talks I've done on YouTube. With that, I've just about got enough voice to say thank you. Good night, Vienna.